Okay, class, it's Mr. Zabo. Time to review what we talked about yesterday with LT28 in our first activity here. We talked about the graph of our parent function for the reciprocal function is a little bit disjointed here, and it's because we have two asymptotes, one vertical asymptote at x equals 0, one horizontal at y equals 0. That is going to give me a range where my y cannot equal 0, since we will never cross the x-axis, and a domain of x not equal to 0, because we are never crossing the x-axis. And our graph, we talked a little bit about how our end behavior is different here, that as x approaches infinity, the y value is getting closer and closer and closer to 0, but never getting there, never touching it. So as x approaches infinity, y approaches 0. And as x approaches negative infinity, so going to the left, that our y is also approaching 0. It's just approaching it from the bottom. Okay. Then we talked about the transformations and how our parent function, 1 over x, can be transformed. And when we do that, we are transforming our asymptotes, both our vertical and our horizontal. When we add or subtract to the x value in the denominator, that is translating our asymptote left and right, so it translates the whole graph left or right. And when we add or subtract after our function at the end here, that is going to be a translation up or down, so our graph moves up or down with the asymptote. The other part we talked about was the value in the numerator. In the parent function, it's a positive 1. If I make it negative, that reflects the graph over our horizontal asymptote. And in parts C and D, we also stretched the graph. So you can see in part C here, not only does the parent function is that dashed line, but if I multiply 1 by 4, that's going to vertically stretch this graph. So I'm going to make it appear like that kind of little vertex of the curve there is moving away from the intersection of the two asymptotes, and that's what it's going to look like. Okay? And in part D, we did both. We reflected it and we stretched it quite a bit. So that's a quick summary of what we talked about at the beginning. And then we saw the one example, and we didn't quite finish it. So I want to take a little bit of time now to, again, review and go over this concept here in our post activity that we ended with. Our parent function is always 1 over x, even if I have a different value in the numerator. And we'll talk about that in an example in a little bit. Okay. So one of the things, and this is how it's going to be asked of you on any assessments. Okay. What is the parent function? It's not 1 over x. It's y equals 1 over x. That matters. Okay. We can identify our transformations. In this case, a shift left 1 unit, down 2 units. That gives me the information on where my asymptotes are. Okay. Instead of at x equals 0, it's moved left 1, so it's at x equals negative 1. Instead of at y equals 0, it's moved down 2, so it's at y equals negative 2. That concept also flows right into my domain and range. Since I have an vertical asymptote at x equals negative 1, my x values will never equal negative 1. A negative 1 would make my denominator 0. Okay? And since my horizontal asymptote has shifted down 2 units, my range has y not equal to 2, or negative 2, I should say. The part that we have to spend a little more time talking about, again, is that x and y-intercept at the bottom. When we're going to ask you to sketch this on an assessment, I'm going to want to have at least 1, if not 2, data points. The rest is all going to be kind of general sketch, and we'll talk a little bit about the reflection and the symmetry here in a second. But you have to remember that if I want the x-intercept, that means my y value is 0. And if my y value is 0, I can substitute that into my function for y here and solve for x. The tricky part on solving for x is this step right there. And when I'm solving that for x, and x is in my denominator, I have to multiply both sides by the entire denominator, the group of x plus 1. It's not just multiply both sides by x. That won't work. X is not on its own down here, it's x plus 1. And this is a concept that we're going to spend some time on tomorrow as well, is this idea of having a binomial in the numerator and denominator, and if those binomials are the same, that equals 1. So they reduce. And that gets rid of the x on the right-hand side here, and it leaves me with just the 1 from my numerator. On the left, I have to distribute that. That's not just 2 times x, it's 2 times x plus 1, so I have to distribute to get 2x plus 2. The rest is solving a linear equation like we did in Algebra 1. We get negative 1/2 for my x value when my y value is 0. I plot that point. Typically, the y-intercept will be a little bit easier because I make my x value 0. And if my x value is 0, I can just simplify this fraction. 1 divided by 1 is 1. 1 minus 2 is negative 1. So what we'll ask you to do is plot those 2 points. We want to see that as being visual. I want to see those ordered pairs plotted on your graph. I would like to see these very lightly dashed lines representing your asymptotes. They're not officially a part of your graph, but that is going to help give you an orientation for where your graph is going to be. Once you have the 2 points plotted, you have a general sense of where and how to draw your curve. Get up to and close to your asymptotes, but don't touch them or cross them. Okay? And when you have one of them, the other is symmetrical. Okay? And it's going to be kind of like a reflection over x and a reflection over y. So this was pretty darn close here to that intersection of my asymptotes. This should be pretty darn close to the intersection of my asymptotes. I don't want this graph here on the bottom. I do not want to see that graph just be kind of arbitrary like that. That's not going to cut it. It's got to have some symmetry to what we're looking at there. Okay, so that's kind of looking through and talking through quickly this example here. What I'd like you to do is go to the next page and there's a second example on there. So you're going to press pause, you're going to go to the next page, and I want you to complete that entire problem. Identify the parent function, the transformations, identify your asymptotes, your domain, your range, your intercepts, and sketch a graph. When you're done, unpause to come and check your work. All right, so this one had a bit of a trick to it. You had to be really careful here. The parent function's y equals 1 over x. That is always our parent function when we're talking about reciprocal functions here. Okay, the tricky part here, there's a couple of them. That negative is representing a reflection over the x-axis. And that's going to come into play. We'll see that once we can find the intercepts, x and or y-intercept. The 2 is a stretch by a factor of 2. It's a vertical stretch by a factor of 2. And my x minus 2 is representing that I am translating this or shifting this to the right 2 units. So I have my asymptotes sketched. I have the equations. It's not 2 and 0. X equals 2. It's an equation of a line. You are required to write it in that proper notation. Okay, same thing with domain and range. Okay, since my asymptotes are at x equals 2 and y equals 0, I still have that asymptote, even though I didn't shift this or translate this anywhere. That's still an asymptote. That still gives me my domain and range. This concept that my range is still y cannot equal 0 means I can't find an x-intercept. If y doesn't equal 0, I will not have an x-intercept. And that's okay. Okay. We just say that there isn't one. That's not applicable. Okay. But I do still have a y-intercept that I calculate and I find. And that's the time where I'm only going to have one point that I can graph on my graph. I'm not going to graph an x and a y-intercept. I'm only going to graph this one. But that's enough to give me a general sense of what this function is going to look like. And it's reflected over the x-axis. So it's not in the same sort of quadrants that our previous function was in or that our parent function is in. And we can see that evidenced, this reflection, based on where that intercept is. Okay. All right, one thing I'd like you guys to do right now is, if you're stuck, if you're confused, press pause, and somewhere on your notes at the bottom here, write down 1, 2, 3 questions. And then when I'm back in, I can help answer them. But you also know what types of questions to ask at this point. You can talk to the sub. The sub will be able to answer some of your questions, and I'd be happy to work with you when I'm back in as well. Okay? If you're good and you have no questions, move on. Go to the next page. There are two questions at the top that are a little different. I want to see you try. You're going to write the equation for the translations that have been described for you. And then there's one extra problem at the bottom that is going to be similar to the two that we just did. So pause, try those problems on that next page. All right, and to start with number one, okay. Now this 5, that doesn't make this the parent function. That just means this has already been stretched, but I'm now performing these other additional transformations. Translate left 3 units, so I'm going to add 3 to the x. I keep the y equals 5 over x. Down 2, I'm going to subtract 2 at the end. Okay. This reflect over the x-axis means I'm going to have a negative 7. It's already been stretched by 7. Now I'm reflecting it. And then the same idea with my transformations. I have asymptotes that are representing those translations. Okay. Again, questions? Put a star here. Write down your question. Send me an email. Talk to the sub. Ask your classmates. Okay. Make sure you're understanding this as deeply as you can right now, and then asking questions to help you understand it deeper later on. Okay. Last one, if you haven't done it already, pause and do number 2, please. All right, and here we go. We have stretched by a factor of 4. Okay. We have shifted this left 3 units, up 4 units. Parent function's the same. That gives me my asymptotes left and up. That gives me my domain and range. Okay. I can see my asymptotes on my graph, and I actually have an x and a y-intercept. And again, finding that x-intercept can be tricky. Make sure you're very careful with your algebra there. Finding the y-intercept. Hey, yeah, it's a decimal, it's a fraction. That's okay. Things work out that way. Okay? And you just get as close as you can to that value when you're plotting that point. All right, at this point, you are done learning this part of LT28. Next thing to move on to is the worksheet that I am going to have you guys working on. It's going to be just more practice, just like this. Make sure you're asking questions of each other, of the sub, and of me.